Welcome back, viewers. In today's class, we are going to be looking at hybridization as one of the topics in chemistry, inorganic chemistry. And based on the fact that this series of videos I want to be releasing now are in higher demand, so I'm going to make sure I'm brief with everything. All right, hybridization straight to point. Now, the word hybridization means, or it can be defined as the mixing or blending of atomic orbitals. The mixing or the blending of atomic orbitals is what we call hybridization. When we blend atomic orbitals, what do we get? We get what is called hybrid orbitals. And hybrid orbitals have equal amount of energy. Students should take note of this. All right? Of course, from the basis of chemistry, secondary school days, we know S, P, and D orbital. There is also the F orbital. But for hybridization, we are not going to include that on fourth one. So what do we mean by hybridization? When one orbital is mixed with another. So what I'm saying in essence is we are not trying to blend S and S or P and P. So but we are going to be blending with S with P. Okay, we can equally blend S with 2 P's, S with 3 P's, but we cannot just say S plus S, like blending S and S, and we cannot just say P plus P and blending P and P just like that. No. Before we carry out this hybridization, one orbital must be blended or mixed with another one. So moving on now, class, it is important I tell you now that for inorganic chemistry, we have the following hybridization. That is the following hybridization what you're going to meet in the exam. All right, so we have when we blend S with P, that is S and P. If you blend it together, we are going to have sp hybridized orbital. And it is possible I blend with S plus P plus P. In that case, I'm going to get sp2. All right, but I don't want to be writing it like this because it will take my time and space. So I'll just go ahead to give you the types of hybridization we are going to encounter in inorganic chemistry, or we encounter every day. So for some question that says, what is the hybridization of H2O, water molecule? Of course, your answer must fall within the ones I'm going to write out here now. But it is important I equally tell you that for inorganic chemistry, when we talk about hybridization in a molecule like this, we usually talk about the hybridization of the central atom. This must be noted. The hybridization of the central atom. So whoever is asking you, what is the hybridization of this water molecule, is asking you, what is the hybridization of the central atom in H2O. So moving on now. So I said, these are the various ones we have. So of course, the first one is sp. Second one is what? sp2, hybridized. Then third one is sp3. Fourth one, we have sp3d. And we have sp3d2. And lastly, we have sp3d3. All these are the types of hybrid orbitals we encounter in inorganic chemistry. All right. It then means in effect that if you're in the exam hall and the examiner asks you, what is the hybridization of compound like this, CH3 minus? Or what is the hybridization of SF6? Or what is the hybridization of xenon tetrafluoride, XeF4? Your answer will fall within all these ones here. All right. But based on valence shell electron pair repulsion, which I'm supposed to teach as a normal way of determining hybridization, this video is not intended to go that deep to explain to students how to draw Lewis structures, and through the Lewis structures of all these molecules get the hybridization. For example now, if I give you a molecule like CH4, of course, how to determine hybridization of molecules like this? We say we use valence shell electron pair repulsion. This theory, vast part theory. We use this theory, valence shell electron pair repulsion, to determine the hybridization of molecules like this. But when you want to do that, you first of all draw the Lewis structure of each of these molecules before you will be able to determine the hybridization. But to save us that, imagine now you're in exam. Maybe you have 80 questions, multiple choice question, about 80 questions within a short period of time given to you to answer. If you are to be drawing the structures of each of these compounds, it will take you a lot of time in the exam before you can get your answer. Therefore, we have devised a means of getting answer easily. So I'll give you a formula by way of shortcut you will use to determine hybridization of all these molecules. All right, I'll go ahead to drop that. So I'm going to drop the formula here. The formula says hybridization H. I called my hybridization. Some persons can call it number of electron pairs, but mine, I like calling it hybridization, is equal to half, open bracket, VEC, all right, plus U plus A minus C, close bracket, that's all. This formula is by way of shortcuts that will give you answers to hybridization questions easily. It's important I tell you that from this shortcut, which I'm going to explain now, any answer you get, if your answer you have is 2, then it then means that the hybridization of the molecule is SP. If the answer you have is 3, it then means that the hybridization of that molecule is what? SP2. After all, for 2, there are 2 orbitals that we blended to get SP hybridized orbital. Then, if your answer is 3, you have SP2. Of course, how many orbitals do we have here? 3 of them. 1s and 2 p's. Which means that from this formula, when your answer is 3, then the hybridization is SP2. Then for this one, when your answer is 4, of course, you have SP3. When your answer is 5, you have SP3D. When your answer is 6, you have SP3D2. When your answer is 7, you have SP3D3. So that's how we do it. Then the next thing I need to tell you is, I need to explain the parameters that are in this formula now. So from our formula, half is half. It then means that half is multiplying everything here, or everything here is divided by 2. That's how we do it. So what is VEC? This VEC stands for what, class? Valence electron. Valence electron of the central atom. Of the central atom. One problem that many chemistry students have is this problem of cramming. Most of chemistry students cram chemistry. All right? So when you say valence electron, some people define it as valency. It is important I tell you, valence electron is not valency. What we call valency in chemistry is the combining power of an element or radical. If you are an element and I'm an element, and we want to combine, what we make use is our valency. All right? But when we say valency electron means the electrons in the outermost shell of an element. Electrons in the outermost shell of an element. That's what we call valence electron. Okay, but here we said valence electron of what? Of the central atom. Of course, if I give you molecule like this, CH4, and I give you H2O, there is always a molecule at the center. For example, for CH4, if I should draw the structure C, H, 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 and H, that's what we have. It then means there is an atom at the center here, and then there are other atoms that surround the centrum, which is hydrogen. These other atoms that are surrounding the carbon are called the peripheral atom. Meanwhile, the atom at the center is called the central atom. So what we are saying in this formula is that locate the central atom, find the valence electron of that central atom. That is what you put here in your formula. So moving on now. But the question now many students will ask, how do I know the atom that is at the center? Don't worry yourself, I got you covered because I want to make it easier for you. Class, look at this now. Okay, let me see add this one, CH3 minus. If you are asked, what is the central atom here? Class, look at this now. There's one atom that is 1 here, and there's another one that is 4. The one that is usually 1 is the central atom. So you don't need to waste time on that. So look at this, C is 1, H is 4. So C that is 1 is the central atom. What about here? Hydrogen is 2. Which one is 1? Oxygen. Oxygen is the central atom here. What about this place? Carbon is 1, hydrogen is 3. Central atom is still carbon. What about xenon tetrafluoride? What is the central atom? Central atom, xenon, because it is 1. Fluorine is 4. Alright, so the atom that is usually 1 is the central atom. Alright, so moving on now. We now have the U. What does the U stand for? The U stands for univalent. Univalent. What are univalent? Univalent are hydrogen, okay, and halogen. Hydrogen and halogen. Of course, halogens are elements are in group 7. Chlorine, fluorine, bromine, iodine, etc. So when you have them in the molecule you want to find the hybridization, as many as they are is what we put here as your U. So the U is either hydrogen or halogen. If hydrogen is there, you ask yourself how many. That is your U. What about the A there? The A there stands for what, class? Anions. And of course, from the basis of chemistry, anions are what? Are they negatively charged or positively charged? We said that anions are what, class? Negatively charged ions. So if there is a negative charge in the molecule you want to find the hybridization, that is what you take as your anion. And what do we do to the anions? We add them. Then what about the C there? Of course, the C stands for cations. And what do we say we do to cations? We subtract them from the formula. Right? Cations are positively charged ions. Positively charged. Positively charged. So this is explanation to the formula. The next thing we are going to do now is to write out some molecules and then try to use this formula to predict their many things about them, the geometry, the bond angle, the shape, and etc. All right. But for this first video, what I'm focusing on is how you can determine the hybridization of a molecule using this shortcut formula here. Now, do well to pause the video and copy out everything here because I will wipe this now to start giving examples and how this formula works fast. Remember once again to put this thing down and commit this to your memory. If the answer we get from here is 2, then the molecule is going to be sp hybridized. If it is 3, it's going to be sp2 hybridized. If it is 4, we'll have sp3. If it is 5, sp3d. If it is 6, sp3d2. If it is 7, sp3d3. That's the hybridization. So to determine hybridization, you make use of this formula. Do well to copy out this because I want to rub off the board and now give examples on how this formula works. So without wasting our time, so you can do well to pause the video and copy out the formula. Now moving on now, I will leave this behind so that once I solve any molecule, we refer back to our answer and decide the hybridization of the molecule. Very fast, very fast. All right, let's solve for molecules like this. I'll write it big. So the first one we're going to look at is H2O. So the second one, let's look at CH3 minus. And let's look at, okay, CH4. There's something I want to show you using CH4. There's something I want to explain there as I'm adding it there. Also, there's also SBF3. Okay, of course. I will I will do some and leave the rest for you to do. And then there is also xenon tetrafluoride. So I'll write it up here. And there's also SF6. Okay, and then finally maybe let me add CO2. All right, so I'm going to determine some of this now using the formula I just dropped. So let's solve this one first now. H2O. First of all, what is the central atom, class? The central atom here is oxygen. Oxygen. I said the one that I usually want is the central atom. So I want to determine the valence electron of the central atom. Of course, we write oxygen as O8, meaning that I have 8 electrons to share among the shells. If you share that the first shell takes 2, second shell will take how many? Can take 8. That means what is remaining? 6. If I write that here, that means that the valence electron of oxygen is what? 6. If you don't want to determine it like this, another thing I want to tell students is that the valence electron is the same thing as the group number. If you know the group which the element belong, then the valence electron is that group. Oxygen belongs to group 6. Okay, the valence electron is 6. Xenon belongs to what group? Of course, group 8. The valence electron is going to be 8. That is how we do it. So valence electron is the same thing as what, class? Group number. So moving on now, I want to determine VEC. I just said now that VEC, okay, valence electron of the central atom is what, class? 6. I've just determined that for oxygen. Alright? Now, do I have U? The next thing I need to ask myself is U. Do I have U? Yes. I have hydrogen. How many hydrogen do I have? It's 2. Do I have an anion and cation? No. Anion 0, no positive charge, no negative charge. Therefore, cation is also what? 0. No positive charge, no negative charge. Anion 0, cation 0. Put everything inside our formula. Let's determine. H is equals to half into what? VEC plus U plus A minus C. So how do we do this now? We now say H will now be equals to half into what is our VEC, class? 6 plus what is our U? Univalent 2 plus 0 minus 0. If we solve this mathematics very well, then we'll have H will be equals to half into, okay, half multiplying 6 plus 2 plus 0 minus 0. That will give us 8. When we take half of 8, what do we have? We have that H will be equals to 4. When we have 4, what do we have, class? sp3. It then means that H2O, water molecule, is sp3 hybridized. Alright? So is that easy to determine hybridization? Very fast and reliable. Very, 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 very fast with this shortcut. Alright? Now let me solve one more so that you will do the remaining one as classwork and then send the answer in the comment section. Alright? So let me just solve another one. Okay. So let me just permit me to remove this now. Alright. Let's look at another molecule like the one I have there. CH3 minus. Of course, class, what will be the central atom? From what I just explained now, carbon will be the central atom. Alright, carbon will be the central atom. And carbon being the central atom, what is the valence electron of carbon? What group does it belong? Alright, so that should be 4. Is that not so? So VEC is 4 for that of central atom, which is carbon. Do I have univalent? Yes. How many of them? 3. Do I have anions? What do we call anions? We said that anions are negative charges. Do we have? Yes. How many of them do we have here? Just 1. Because this is -1 charge. Of course, I'm not including the sign here. You can just need how many anions I have. So how many do I have there? 1. Do I have cation? Positively charges? No, 0. Put everything into our original formula. Our original formula says, so I'll bring it here. Original formula says H is equals to half into, okay, VEC plus U plus A minus C. That's our formula. So we say H will be equals to half, open bracket. What is VEC now? 4. Plus what is our U? 3. plus what is our A? 1. Do we have cation? No, minus 0. Alright? So H will now be equals to half into, once again, 4 plus 3, that is 7, plus 1, that is 8. 8 minus 0, that's 8. Put it there. Half of 8 once again, what do we have? 4. When we have 4, what do we have? We say we are going to have sp3. Alright? So CH3 minus is sp3 hybridized. This is how to determine hybridization in inorganic molecules. That's why I said we are actually determining the hybridization of the central atom. Do well to solve these ones here now. Of course, what is SB? SB should be antimony. So you should know all these things, or the symbols and the rest. Alright? So you see all these 1, 2, 3, 4, 5, 6. You can do the rest. You can do XEF4, SFCs, CH4, and CO2. Alright? To just drop your answer in the comment section. So just do this one, this, and this. Drop your answer in the comment section. But before I end this video, there's something I want to tell you. And what is that? About the geometry of these molecules. About their geometry. Alright? So I'm going to just create one simple table now to tell you about geometry. But it is important I tell you, there is difference between geometry and shape. Geometry will be your shape, or geometry will be the shape of a molecule when there is no lone pair of electron in that molecule. So when lone pair is 0, when lone pairs of electron is 0, what does it imply? This implies that geometry, okay, will be equals to what now? Shape. Geometry will be your shape if lone pair is 0. What then does it mean? It means that shape changes when lone pair changes. Alright? For example, I'm going to first of all drop a table now, then tell you what I mean by this. And that will be all for this video. Now, it is important we note that sp molecules, their geometry is what? Their geometry is linear. And then sp2 molecules, trigonal, planar. And then sp3, look at it now. sp3 is what? Tetrahedral. That's their geometry.